Oh, hey, how are you? Great to hear. Yeah, come in. Make yourself comfortable. Like a drink? Sure. There you go. Welcome to the Tech Lounge. Shall we begin? Welcome to the Tech Lounge with me, Christian Chiller. I took a little bit of a break for 2 weeks. Well, I took a break for 1 week. And then the more astute of you would have noticed that I did release an episode last week and then withdrew it because I realized I'd already released that interview. So there we go. Hence, I'm also releasing this episode slightly early to make up for that. It's an interview from last summer. Hence, we talk a little bit about summer with Vinoth from Onehouse AI, a data lake platform powered by AI. It's an interesting conversation, so please do enjoy. I have been talking about and using Raycast almost since it began. It's a drop-in replacement for tools like Alfred and Spotlight, letting you do all sorts of productivity hacks such as opening applications, triggering commands, window resizing, and through a broad plugin ecosystem, all sorts of other things too. Some of my favorites are HomeKit devices, triggering shortcuts, and screen layouts, and also creating Trello cards because I happen to maintain that extension, actually. Raycast has a pro feature, lets you do all sorts of other things, including a lot of AI features and the ability to share workflows amongst other team members. So if you're interested in finding out more, getting a discount on a pro plan, and of course, earning a little bit for the show, then head on over to go.christianchiller.com/Raycast. So Vinoth, how have you been today?
Pretty good. It's a pretty beautiful summer here in California, so
Okay.
life is good.
Good. I was kind of getting the impression it's... And actually, no, well, it depends where you are in California, isn't it? San Francisco can be quite cold.
It can be, but I think this is one of those times where I think the evenings are really beautiful. Even up in San Francisco, I live in the Bay Area, but further down south from San Francisco. But I see what you're.
It's been a long time since I've been there. We were supposed to go to LA a couple of years ago, and then it didn't happen. And so I think the last time was over 10 years ago. I think it's changed quite a bit. What also has changed quite a bit, I'm going to go for an extremely poor link there, is the amount and the way we store data. And so I'm talking to you about Onehouse, which I must admit initially, because we arranged this interview a little while ago, I saw Onehouse AI and I was thinking, what's that about? Then I went to the website, it's like, okay. So this is interesting because there is this, I've had a few people on the show before talking about like data lakes, but you're going for the data Lakehouse, which is an interesting choice of words. I mean, a Lakehouse isn't necessarily very big, but it's kind of, I think you're maybe going for this like boutique feeling maybe.
Yeah.
But yeah, let's maybe unpack a little bit of what is a data lake and why is Onehouse a universal one?
Yeah, that's a great question. And maybe for this, let's take a small trip down memory lane and kind of like go towards where it all started from, right? So my 2 jobs before this company, I was at Confluent and working primarily on stream processing. It had nothing to do with data lakes or data lake houses. But the 2 jobs before that, one was at Uber, building data lakes and what we called transactional data lakes. We'll get into that. And then even before that, at LinkedIn was part of the data infrastructure team, which kind of famously built a Hadoop, HDFS cluster, what amounted for like a data lake, if you will, right? So all in all, here is how I look at it. So, we understand databases really well, like relational databases, like exceedingly well, all of us do, right? And data warehouses are simply like specialized databases which have columnar file formats and let you analyze stuff, slice and dice stuff. It's the storage and the query engine, the optimizer, everything's kind of like written a little differently for that working, right? So where we started with this data lake concept was, it actually started more as an architectural pattern for organizing data, right? I kind of my anchor point was Martin Fuller's kind of description about what a data lake can be and how kind of it's a flexible way for you to store and collect as much raw data as possible in its raw form, and then use the collective, compute power and the storage power that you have in these kind of platforms to then flexibly transform them for downstream data marts. Back in the day, that was like a term that we all threw around, right? So that's kind of how where it started. So at LinkedIn, quote unquote, right, when we had relational databases, I was part of the key value storage team. And then we had all these data applications, like the things that you see on the site today, jobs you may be interested in, people you may be interested in, blah, 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 right? Which all needed crunching of large amounts of data, which needed sort of like, some framework like MapReduce and horizontally scalable compute, horizontally scalable like storage. And that's kind of where data lakes started from, right? And when we went to Uber, I had this, obviously we applied all the tricks we learned at LinkedIn to build Uber's data platform. I was one of the earliest engineers there. And we hit like a wall where we had a data warehouse and a data lake, but we were kind of like not happy with both because we needed some of this warehouse functionality or database functionality on top of data lakes. Because data lakes were pretty much, here's a distributed file system or object storage and a bunch of objects files sitting on it, right? That's what it was, right? So that's where we started this project called Apache Huri, which is, we called it a transactional data lake instead of like, the Lakehouse wasn't the term that we coined. That was credit for that should go to like Databricks like 2.5 years later, right? But we built the world's first data lake house, if you will, before the term existed. And the basic idea was, can we keep this horizontally scalable compute and storage, this efficiency and this architecture intact while we introduce some of the database transactional functionality that we had in the warehouses. And that actually has been, now coming to Onehouse. What we want to do is we believe that is the technology foundation for like going forward for all of our data. When we started the company in 2021, not many agreed. We were, I think, the second Lakehouse after, Databricks, who originally pushed and coined the term, right? And steadily over the last 3 years, like we've seen like, cloud providers or, other data warehouses like Snowflake or everybody, whether they use table format or Lakehouse or whatever marketing terminology they use, we generally are now aligned at a point where we want data to be like stored in open data formats. And in like, you should be able to write and read from different engines based on different use cases. And with similar functionality that we had in database like functionality, right? So this is the technology foundation. What Onehouse wants to do is actually in this new world, deeply coupling storage with your compute engine makes no sense anymore. Because, for example, like the warehouse like Snowflake is really good at like BI workloads. But if you want to do data science, you may already be looking at a Spark platform like Databricks, EMR, Fabric, any of those like 4 or 5 things, right? Or there are new emerging workloads around AI that all, as you know, like open source has like, there's a lot of open source frameworks that you need to integrate with. So we live in an age where data needs to be kind of independent and kind of managed independently from the consumption layer. And then Onehouse wants to be that universal data lakehouse that plugs and plays with any query engine. It can work across multiple cloud providers. It can serve the same data to multiple engines. And this is a model that actually we've seen when we build these data platforms for like, these 2 large consumer internet companies, Uber or LinkedIn. These are the principles that we adopted, right? But by and large, if you look at the industry, though, people typically start with like one silo, like a warehouse, and put all their eggs in that basket. And then when 3 years down the line, they quickly, have a migration project on their hands. So we are essentially turn that model upside down and say, look, you start with your data, right? You can get your data into Onehouse. We are the most open and most interoperable option out there in the market. We work across clouds and engines. Our job is to actually, help you get your data into this form and transform it, but you can access your data from any engine possible, right? And we kind of remove all these different lock-in points that exist in the stack. that's what we're doing.
Just before we dig into what Onehouse, well, everything it is, because it's quite a lot, just out of interest, what you mentioned, LinkedIn, Uber, both companies that, create and process a lot of data on a, minutely, if that's a word, basis. But, what is more likely in a company like that, to actually go to a solution like Onehouse, or do they tend to just make their own? And how much of is that a barrier to a company like yourself trying to convince a company not just to roll their own?
Yeah, it's a great question, right? So, and I think if you look at our own Hoodie, like the project, basically, it powers some of the largest data lakes out there. But to your point, a lot of these companies who can hire like LinkedIn or Uber tend to kind of try and build their own data platforms for various reasons, right? It's because I was on the other side of this equation. We felt like, we wanted more control over our destiny. We wanted people that we can kind of like call and like resolve issues very quickly, like to get the necessary, the uptimes and all of those guaranteed for the business. So there are like various factors that go in. But for every company like that, there is probably like 5 companies who are like also cannot hire, like, because here's the thing, right? Remember when I told you we turned the data lakes, which are just files on top of a distributed file system like thing, to a introduce database functionality. But now this new technology, but you need almost like DBAs to run this thing, right? Because you are operating a very large scale database if you're operating a data lakehouse. So a lot of companies don't have that kind of like talent, right? And are even if they do, sometimes they don't want to kind of take that on because it's kind of not very differentiating work, right? So for example, moving data from Postgres, MySQL, or relational databases into a lakehouse is like a very something that is not a business moat for any of these companies, right? Like which are, let's say you are a retailer or you're a bank, that's not your moat, right? So there is that aspect, operating these systems, any complex distributed data system is not an easy walk in the park. So there are all these different reasons why still people turn to a solution like Onehouse, but we make it very clear that if you think you can operate on its own, we believe not just in open formats, but also in open compute services. So Hoodie as a project provides you, for example, like an ingest tool, which a lot of these companies run. So if you can build and hire the team, you can run it, operate on your own. But if you cannot, then Onehouse can step in and help you be more efficient.
And what are the open formats in this space?
Yeah, so that's a great question. So in format itself, I think I would kind of like divide it into 2. Like one is your actual file formats, which is where the data is stored, right? So when you look at data lakes, you're typically looking at columnar file formats like like a Parquet or ORC, which are the most prominent ones. And then you have row-based file formats like, there's still Avro files around. There's also a lot of data outside of these, right? Which are, unstructured data formats and many other things. But by and large, I would say Parquet, ORC are the most prominent file formats.
Parquet, and what was the other one?
ORC.
ORC. Okay. Yeah. So all of the tools that are part of this kind of system use this. So I mean, this is a world I've dipped my toes into, but like I understand, Kafka streaming, SQL storage, MapReduce. Like, are they all communicating in those same formats, or is that there's multiple formats between them?
Let me try my hand at unpacking this. So the lowest layer you have cloud storage, and then on top of this you have these open file formats, right? On top of this, what we have is like what's called a table format, right? So essentially something that can group these files together into, let's say, consistent snapshots, or something that gives you like a change log or a redo log, if you will, to implement some kind of like, write semantics or something that, so there's a bunch of like metadata basically sitting on top of this. And Hoodie, Iceberg, Delta Lake are the 3 prominent kind of like, so I think people call it Lakehouse storage or people call it table formats, whichever. So it's a layer on top of these file formats, which lets you kind of, like make sense out of like a group of files sitting in like cloud storage into, okay, here is a table, right? Here is something that, And then it unlocks a lot of cool features, all three of them, right? You get time travel, you get time travel queries by retaining enough snapshots. You kind of like, on the writer side, you implement some concurrency control to allow two writers to write to the table and the whole bunch of these functionality. And they do also differ. For example, like Hoodie, we focus a lot on non-blocking concurrency control techniques and, more heavy investment into indexing subsystems so that we can, because we were optimizing for incremental writes and incremental reads.
Yeah.
So you can see, right? You can play with the layout and you can tweak these layouts. Just like, for example, MySQL has 3 storage engines. You can actually organize data differently and you can come up with kind of different table formats optimized for different kinds of workloads. And by and large, if you now move up the compute layer, I would say, again, I'm speaking purely about the open source stack here. Spark is taken more over the place of MapReduce as this general purpose vanilla engine that can do, like, it can do, streaming reasonably well. It can do batch processing. It's the mainstay for batch processing, right? And it lets you write programs which are, I would say, multiple stages, right? You can chain. So yeah, there's a lot of obviously a big ecosystem around Spark. And then you have specialized query engines, which are, I've seen people use like Presto, Trino, there's a bunch of these query engines, which are essentially SQL OLAP query engines, which do vectorized query execution. Their main goal is to provide lightning fast queries on top of probably like data produced by ETL pipelines written in Spark and obviously Flink, since you're already familiar with the streaming. So this is a general stack that we see out there. The last 3 years, what's happened is, as you know, warehouses have been, and still predominantly the default formats inside cloud data warehouses is a proprietary data format, right? Because like I said, everything's been vertically optimized. They start to open up that SQL engine also to these open table formats or open file formats in a more efficient way. And that has been a major kind of shift in the architecture now, because now the same copy of data, so typically people used to ETL on the lake and then copy the data into a warehouse for serving. A lot of people still do that, but this suddenly opens up the possibility of simply using warehouses as query engines for the first 2 layers directly. So that's generally what's going on in this space, I'd say.
You've mentioned the word open a lot. Let's move up the layer. So because I went looking for spelling it the normal way, but it's HUDI, which I just want to say is Hoodie. I don't know. When is that not enough, and do people need Onehouse? Beyond kind of SaaS offerings, someone to complain to, etc. Why would someone technically need to come to Onehouse instead of Hoodie?
Yeah, I mean, first, like I mentioned, there is, regardless of what technology you pick, there is operational overhead, and you need to have a 4-person data engineering, 4-person team to build a data platform. So if you that's first reason. But more technically, right? I think what we've seen is, even if with a technology like Hoodie and you have open source compute engines like Spark and Kafka and Debezium and this and that, you still have to assemble 5-6 open source projects really well to actually build or get the functionality of what a proprietary vendor will sell you on the cloud. And so essentially we saw a gap, and we see a gap in the market where you either go buy something super proprietary and that gives you ease of use, quick time to value, or you build your own team and build and hire and train your team to build a data platform, which takes probably 6 months to a year. Right. So people who are, there's no middle ground here. So we want to be that middle ground where, we can help you get started with your data lakehouse on industry leading open foundations on day one. That's one of the core reasons, right? Specifically on Hoodie, this is what we see. People a lot of companies have built, large data lakes on top of this, this Hoodie Lakehouse storage, and a lot of these engineers are really good at SQL or writing pipelines, writing Spark, Flink jobs. That's their trade, right? But when it comes to actually, if you double click up the exec level, what they want is, I'm building a lakehouse to replace a lot of my reduce cost of my warehousing stack or something like that. For you to actually achieve that end goal, you need to optimize these tables and do stuff to these, like, operate it in a way that it's like as good as that, right? Like if you look at Snowflake, BigQuery, Redshift, any of these things, the warehouses are like, they hide all the file level stuff from you. You deal with a much higher level of abstraction, and there are services that optimize your tables. So that's the second part where I think a lot of Lakehouse users, even, they struggle to get that part really optimized. So at Onehouse, what we offer, we launched this with our recent Series B announcement, which is a table optimizer service.
Yeah.
So people are able to keep their existing business logic, their Spark Flink jobs, and simply use us to optimize their tables, right? So this also has the benefits of centralizing like data management. For example, clustering is a common technique used in warehouses to improve query performance. So we can cluster the data once in this like Onehouse data layer, and then you can reap the benefits of that clustering across multiple query engines, right? So we are able to kind of, that's an area where we kind of like step in and help. Besides okay, I don't want to build it myself. This is not, I want a faster time to market kind of reason.
So you're basically saying that you could kind of bring this long-term desire of, I can use query language I like, even though I'm actually querying data on a system with a query language I don't like.
Basically, data is the lingua franca, right?
Yeah.
So and since we are built on top of these like standard open formats that are supported pretty much everywhere by all the major engines in the market, we're able to kind of and that's the biggest reason that we see for companies to switch to this Lakehouse model is, looking backwards, I think when we first moved to the cloud, right? Data moved to the cloud was when we decided, oh, look, like our on-prem data warehouses are not going to scale anymore because the storage and compute are tightly coupled, right? Then we went into the cloud with, like Snowflake and BigQuery famously kind of decoupled that compute and storage. So it gave us the ability to store a lot of data. So life was good for some time. But now what people are realizing, 3-4 years in, post that move is, there are many use cases. So I'm going to have to end up building a data lakehouse or a lake or whatever you want to call it, like ultimately anyway. So I want to start with a architecture like that. So that's the biggest shift that I see is going on right now. And we are squarely, our services just like, help you just get you jump started into a data lakehouse. And from there, you can go use Snowflake downstream. You can use Databricks downstream. You have the options. You have the freedom of choice to pick whatever.
So actually on that, like just to dig into a little bit. So people, you have a lot of logos here, and I'd like to go into a couple of those in a minute, but these are all services that people have running somewhere else and they use you to connect them. You're not, or are you also providing them? Or both. I don't know. What do people have to have when they come to you? Are they bringing their own services, or they migrate their services to you? Are you a connector, or are you also a provider?
No, so we are a compute provider. So what we provide. So when people come to us, they typically have data sitting in relational databases, NoSQL, or even Kafka and the ilk, or files in cloud storage, maybe even that. And they're looking to build a data lakehouse out of that. That is kind of what.
I just wanted to double check, because sometimes some cloud services are just the kind of connector, the manager, the orchestrator, and others can be everything. So there's a lot here. We've got warehouses, query engines. Some of the logos I recognize, some of them I don't. Engineering, data science, databases, data streams, cloud storage. I don't know how much of this is provided by Onehouse versus Hoodie, but what was the engineering challenge like? Just being able to make all these things talk to each other, and how did you go about it? These kind of interface tools, they always seem like a great idea, but then technically it ends up being so complicated to try and actually to get work in a reusable way.
Well, that has taken time, right? More than so. The part around, I'll talk about like what we build in Onehouse versus like what's kind of like out there. But high level for me, that's taken like 8 years from the building the very first data lakehouse, which was the transactional data lake, if you will, which, as you can imagine, was like very controversial, not so well liked idea when we first did, to the industry right now where you have CEO execs across clouds and big vendors basically saying, yeah, we need like to embrace open data formats, right? So it's taken time, but the actual technology advantages that you're getting, business that have built, have the success stories have actually helped pave the path where most of those integrations that you like just talked about right now have organically happened over the last 3 years and change as the data lakehouse as a technology category became mainstream, right? So that is we had to build one particular thing, which was we felt kind of taking the spirit of openness away from the whole data lakehouse, which was a project called One Table, which originated as One Table. The basic idea was, like we again saw, even though the file format was, let's say, Parquet, there were lock-in points kind of people were trying to build using this metadata layer on top, right? So we built this project which basically keeps one copy of data in Parquet and then produces metadata in all three table formats. So, and this project now, is something that is incubating again in the Apache Software Foundation as Apache Xtable, and has like broad support from across the aisle as well. So this is one move that we needed to make, and we felt like this is probably the first time we had a project aimed around interoperability in the industry. We never talk about interoperability, right? We typically talk about unifying around the current shiny thing, and then we go to the next shiny thing. So that was an interesting thing for us to build, and kind of we had to work with the entire vendor landscape to make that happen, right? And from a Onehouse standpoint, what Onehouse provides is, think of it as pipelines and data management, right? So we provide all the ingest, the ELT, ETL tooling that you need to move data from your external kind of like data sources into the Lakehouse and further transform this data within the Lakehouse, right? And then all the different areas that you had, for example, like Flink integrates with like our storage layer. You can basically query the data using any of these tools. That integration is already there. And like I mentioned, we also manage this data centrally once, so that you can be clustering the table once, and you can build indexes on this data once and stuff like that. So what we provide are, almost think of it as the bottom half of a database. We provide storage, storage management and optimization. And then we provide like pipelines to, keep, kind of like move data in and transform data, right? And the other interesting thing that we provide is, as you know, each query engine that you see on top has its own data catalog. Right. Yeah. And then data catalogs are in the query fast path. It's like something that is very hard for the industry to kind of agree on one thing, right? Because you need, for example, when you query a Snowflake or like Presto, they plan their queries, they need to call something really fast. It needs to return the exact kind of information that planner needs and all of those things. So what we do is we also have this multi-catalog sync service inside Onehouse, where we can expose this single copy of data as a table into multiple different catalogs. So the same physical single copy of a table will appear as a table inside AWS Glue data catalog. It'll appear as a table inside Databricks' Unity catalog. It'll appear as a table inside Snowflake's catalog or Google data catalog, what have you. And then that makes it like super easy. So you can essentially ingest data, transform data, produce tables, manage them centrally, and then register them into catalogs. You can add a new query engine by simply enabling that catalog. And since most of these engines can read some of these like open file table formats, it basically, you have like a really seamless experience when it comes to access. So we are essentially decoupling the storage management, that layer, from the access layer, as I originally mentioned. And we believe this is the right model in the cloud, because you already pay for S3 and EC2 separately, right? Like, so kind of bundling these vendors together is some kind of like an on-prem hangover, right? Because it's the only way to operate on-prem, but cloud changes that completely.
Now, no company is complete at the moment without jumping on AI in somehow.
Yeah.
And you've added, well, Maybe you can give me a bit more detail, but you've added some sort of integration with vector databases, I think. Vector embeddings, maybe it's not quite the same. Is that different from a vector database, or is it similar-ish?
Similar-ish. It's vector embeddings is what you store in a vector database.
Okay.
So what we've announced pretty recently was, remember how I talked about providing ELT, ETL pipelines to move data from your external systems or transforming them to produce Lakehouse tables. We basically added support for customers to come in and say, okay, look, like this field in my Postgres table, please generate vector embeddings out of it by calling OpenAI, like another external foundation model, and then store it in the Lakehouse. Yeah. So what this does is it brings all the benefits of data management that data lakehouses provide to managing vector embeddings. And this is something that we built by, again, observing people in open source. There are enterprises which are kind of, once you are past the, I prototype something, I want to now move to production kind of, point, then you need to do this at full scale of your data. Then you have the core data management challenges around how you manage vector embeddings. Yeah. The last part is, most companies run multiple, even at medium scale, they run multiple vector database instances, right? Yeah. So a data lakehouse can act as that, central source of truth, where you can, move pieces of that vector embeddings into different vector databases downstream to do the actual serving. So we're not replacing vector databases. We are actually helping with the pipelines for vector data, generation and data management.
It's actually kind of interesting. As far as I understand it, in a very high level way, you're actually allowing people to create embeddings based on their existing data, which is very powerful, actually. Yes. They could have it in all these different places, and it's been sat there for decades. And now they also want to jump on the AI bandwagon. And in order to do that, they're probably, how do we access all this data and do something with it? And then you're giving the potential to do that. Interesting. Okay. All right. As we sort of get to an end, I mean, those are two fairly big announcements. You've got that. You've also got the Table Optimizer and Series B. But what's next?
What's next? Wow, that's a great question. So I think the biggest thing that we are still, focusing on is, we continue to, even as like a small startup, we continue to kind of shape the technology landscape for data lakehouses. So like I mentioned, we introduced several new database kind of techniques into the data lake realm, like indexing or change capture or incremental queries, and the list goes on. So a lot of what we're thinking about now is how we kind of, bring unstructured data and how we continue to expand the thing, right? Bringing unstructured data into, the similar kind of management as what we did for structured data. Also, kind of, should a lakehouse, what's the end game for a lakehouse? Should it look more like, should it be a serving layer? Or should it be this scalable storage transformation layer and with some serving, but we always have a specialist serving layer. So there are all these open technology challenges that will define what Lakehouse is. And I think we have so this is on the technology or the open source kind of front. And on a product, I think what I would say is we have a pretty interesting and a unique product where it kind of, so we do data ingestion, but we are we do it in a way where we are essentially having an opinionated take on how your data should be organized. And, it should be open is the only option on Onehouse, right? We don't sync to a proprietary table in a warehouse. So essentially on that side, I think we have a pretty unique product already. A lot of our efforts are, and with the funding and everything, is to get more serious momentum, a lot more, customers, a lot more usage, and get the product adopted a lot more over the next 12 to 18 months. And that's kind of what we plan to do. Even as we, work R&D, we invest in furthering the data lakehouse technology.
Yeah. It's interesting. So if people are interested in finding out more, you do have a $1,000 free credit for 30 days. I'm assuming, the sorts of people who are probably interested in trying this, it's not necessarily going to be small projects. It's going to be mostly people with fairly large data requirements. But of course, the level down from that, you have Hoodie. If people are interested in the concept but would rather do it themselves, yes. There is that option too. So, yeah, interesting stuff. And thank you very much for joining me today.
All right. This is really fun and a lot of fun questions.
So that was it. That was our guest today. Thank you very much for joining me in the Tech Lounge. I have been Christian Schiller. If you want to know more about Tech Lounge, head on over to christianschiller.com or please tell your friends about us. It's quiet and cozy in here, but the more listeners, the merrier. You can find more at christianschiller.com/podcast or in the show notes or episode notes, wherever you found this podcast. Thank you very much for joining me, and you're most welcome next time.